Second, I think we can catch like a 30-second, 1-minute break. I think the amount of the number of services and many other things that I heard in last some time, it would practically take, even for me, it would take somewhere around 6 months to kind of fully understand. But nowadays, I mean, it is very difficult to say what is what. Eventually, one day, EC2 will also be serverless, so will be another. Still low enough, simple. Okay. Well, I'll keep it very simple. We'll go. You can interrupt me in between if you feel that. Okay. I'm basically from Surat. So everything will happen. If not today, tomorrow. If not tomorrow, we'll figure it out. Okay, next week also we'll have time. So rest of the things are fine. I'm only because of the context of this particular event, which is around serverless, the concept of serverless is getting blurry. Like I said, everything is serverless. So I set up my first physical server, something that you need to basically kind of put an order, fill up a form, explain to various people in your organizational hierarchy that why you need a server, what will you do with this server, what are you going to run in that, what it will do as an outcome, all those things. And then eventually it will arrive. So that is back in 2005. I think I remember correctly, late 2005, I set up my first Dell PowerEdge. How any of you have seen Dell PowerEdge? It's a large. I have one at home. It requires 4 people to lift. But it's nice. Those were nice days. Very simple. You have everything available right in front of you. You can do whatever you want to. So from that and over the period of time, still low enough, right? From physical servers to cloud, virtual hosting. I remember Prashant mentioned Rackspace. I was using Linode, small company back in UK. Very good support. Their servers, I used it for good long 3.5 to 4 years. Not once went down. So everything is still good. I was running Java systems. LifeRay. Anyone have heard of LifeRay? Nice. So I used to write a lot of code in LifeRay. Sorry, I'm still putting my head around after there is like so many things. So then I started, so I had, this is my third company doing cloud consulting and development and everything. So I had multiple companies before this, and I was kind of, we had a product, it was a hardware software, like every other product. For many other people it didn't work. But I learned a lot of technical things out of it. And in that, we had a use case of processing large media files. I was taking the photos from DSLR camera, and I wrote the code to capture the photos from DSLR. And in 2015, we had like this small size Android tablets, easily available, costly but still available. Not like right now. Right now we have a lot of options, but 2014, 15 we had still limited options. And you can actually patch your, I figure it, we can patch our Android tablet with DSLR via the USB cable, and I can download the images, raw images. But DSLR has a very high density, big size images. So usually it is 3 MB, 4 MB, 5 MB, 6 MB. And as a part of the overall use case, I had to show it to another screen. Like this screen, we had a screen in an event. At what site we take the photos, we need to show it in another screen. But there was not enough network connectivity. And there was the uploading the photos and downloading it into the next screen using the connected, whether it's AngularJS is something that we were using that day. It was taking a lot of time. 6 MB of photos to upload and then 6 MB of photos to download. So that was the first time I used Lambda, because in that particular use case, it gave the perfect value. At that time, the Lambda didn't have API gateway. How many of you know that the API gateway was not available when there was Lambda launched? So API gateway was something which came later on, probably towards the second half of 2015, middle or second half, I don't remember exactly. But there was no API gateway, so there was no entry point. Okay, the endpoints or the URL that we call, which actually kind of receives a request and transfers it to the next system. There was no entry point. It was just the Lambda. And then one of the earliest trigger available was S3. So I decided to upload these images into S3, and immediately it can kind of trigger my Lambda function. And at that time, AWS was also kind of giving the very simple explanation of how you can use this ephemeral compute. Okay, so ephemeral compute is that you have a very specific small use case and you want to execute a code for that particular use case. It's not a long running process. It's not something that you want to run for hours or days or weeks. This is something you can upload and just wait for something to happen. Okay, so in the moment, it was a very good value addition. Okay, and that was my first entry point to the event-driven architecture. I was doing I will be able to execute my code. If it happens 10 times, I will be charged for the 10 times. If it happens 100 times, I will be charged for 100 times. If it happens 10,000 times, I will be charged for 10,000 times. As a technologist, as a developer, and as someone who was running the part business as well, it has a subtle value attached to that. I'm only paying for what I consume. I'm not paying anything extra, I'm not paying anything less. I don't need to go into the kind of excessivity of what will be the size, what will be the form, how long do I need to keep it running, what happens if my product doesn't work out, which it didn't work out, but the part of the solution that I wrote for that particular use case will always work in the context of my use case. So I have listed out, sorry to actually take few extra minutes, but I hope everyone has kind of, at least it has become a bit simpler. My voice still low? Okay. Early stage startup challenges. I have built a few other products in last few years, so I keep on actually reusing the things that worked for me in the past. I've always had a small team. I have never worked in a large team. So small team has a small number of resources. Okay, each resources might be capable, but they have to do a lot of things in the short amount of time. High cost of operational resources, that means you need to oversee a lot of things. Nowadays, simple applications are also not so simple. And as we have been seeing from start of the day to right now, there are many technologies, there are many tools. If I say use this service, someone will say no, I will use something else. And someone will say no, there are some others. So there are a lot of alternatives as well, and everyone has a lot of perspective. Putting all of this together adds a lot of complexity. Okay, instead of simplifying and focusing onto the use case, we are going into the jargons, we are going into let's use latest technologies, let's kind of build something which is fascinating, and then we can actually kind of showcase it better. But not all startups do that. I'll share a couple of examples. Rapid development. We want to put something faster, okay, so that we can see the output. That's what I did when I had my first use case, and I will do it again if I have a similar use case. As a developer, my first inclination is that how fast I can actually put this to work. Okay, not what I can use as a best. I will not think about how my code will react 100 days from now or 1000 days from now. I would rather focus it that how I can actually run my code first. Right? I think that is something a lot of you who have been developing either professionally or for your side projects, you will agree that you want to see your code work first. Okay. So build from scratch versus utilizing pre-built services comes natural. If you are taking this kind of decisions, you will always use something which is available instead of building everything from scratch. And the decision paradox here. Sometimes you feel that you want to spend some time learning something, but at the same time, if you are focusing on the feature development, you might just focus on the code instead of reinventing. A simple example for that is the user authentication. How many of you still develop code for user, like creating new user, authenticating with the password, stuff like that, right? Some does, a lot doesn't, right? And that's why one of the earliest implementation of sign in with Google, sign in with Facebook, sign in with Twitter, sign in with whatever XYZ you come across, that's the easiest way. Why? Because it actually takes away a lot of thinking. You have sign in, you have done the sign in, you have what you need. You need an email address so that you can reach out to them in case of you want to send any notification. So now this becomes a very kind of a subtle part of the entire system. There are many use cases I have seen that just begins with this simple sign in, do it with a Facebook, Twitter, whatever is available, Gmail, and then get on with the rest of the application, because this is not an important part. And rapid deployment. Because we are talking about code has to run somewhere. As Mr. 𝐃𝐻𝐿 mentioned, it's a very informative kind of a session, but it also includes almost 100 different services. Anyone count? Right? So deploying all of this thing requires people. Not everything will be managed by automation. Yes, CI/CD, infrastructure as a code, cloud, your cloud excellence team or your cloud center team, external services, but all of these things are not helping you to move your feature faster. They had a different use case. They were designing the system for Air Canada. How many of you design system for Air Canada every day? Not everyone, right? So their use case is complicated, and probably they might have reached to that point after some point. On day one, they must have started with something very simple. Okay, the context is also very complicated. Not every context, not every use case is so complicated, so that we need to start with a lot of technologies and a lot of tools from day one itself. So the deployment part focuses on how fast you can actually spin up the resources that you require. Sign in for Google requires no spin up. Okay, using some of the services that we'll see doesn't require to spin up everything. It's just either you do point click or you write a simple script and you have the infrastructure services available. That's one of the things. If you see pattern wise, and if you see all the sessions that we have covered from morning to right now, you'll see one subtle pattern: abstraction. Okay, whether it's services like Cognito, DynamoDB, IAM. Okay, all of those are creating the abstraction so that we can focus on what is most important thing. Okay, and everything else is focused by the cloud provider or the service itself. Still low? I'll keep on asking. Low? Okay. I design very simple applications. My applications are filled with a front end, with a web or mobile, some kind of an authentication. Auth-N on Auth-Z is something that has started into the discussion for past few years, but otherwise it was just authentication. We have the RBAC and we have ABAC and we have a lot of differentiator, but otherwise it's a simple authentication. API management. You need API, whether you write it on your own using the Node.js, Python, Ruby on Rails or any other things, but you want an entry layer. Runtime and compute. This is the place where your code runs, whether it's a function, whether it's a container or something else. Integrations. If it is not simple enough, you might have multiple services and you want to kind of exchange the events between them. Databases, every system. Mr. Abhishek was just telling me that every system is a data system now. So even if it is a hello world, you have hello world as a data as part of it. So the database is a part of a normal application. And the storage, if your data is not able to be stored inside the database, you use a storage mechanism. So this is a very standard, very simple kind of an application architecture, whether it is something you design for yourself as a side project, or I would say that even some part of a very complicated applications will also consist many of these components. Now, how simple we keep this or how complicated we make, that all depends on the use case. And it all depends whether you are starting on day 1 or you are at the day 100, 1000 or 10,000. So this is how the application looks. Everyone can see on the back, I think it will not be very easy to read, but it's a like simple monolithic application, everything packaged inside a single application. I still like it as long as it serves the purpose. I think it is a good architecture. You have everything at one place. If you can manage it easily, it's still nice to have. But this has a lot of limitation with time, right? If it's a small team, you are not making a lot of changes. If it doesn't have too many unpredictable usage, I think you will still be fine with that. But as it grows, it will not be fine. Okay, you are doing a lot of things by yourself here. You are writing every single line of code. If I basically I write code in JavaScript, NodeJS, so that means I can use Express.js to build the routes and everything. So I'm actually creating all the routes. If I need to authenticate, I use the passport.js or a few other mechanisms. So for every single feature, I need to keep on writing the code, okay? And then kind of manage it throughout the life cycle of the application. So for a simple application, it is fine, but not for an application which you are expecting to grow, okay? So in that case, the first concept that we see, always miss something, or you will not be able to implement it exactly like it should be. Like user authentication is a very simple example, but there are hundreds of features in the user authentication as well. There are 100 ways it can break as well. So there is no easy way to implement the full user authentication, authorization, token validations, JOT tokens, security and all those things. So it's always good to actually use the services that can be utilized instead of building something on your own. And the time to market. You want to build and deploy something faster instead of spending time on something which is already available. The second thing, a lot of people will say, if this is something which comes into a professional environment where you are using something, people will say that it will create a lock-in. If we go with this approach, we'll always have to use AWS. If we go with that approach, we'll always have to go with Google Cloud. But the lock-in itself is a very manageable part. You are locking into something one or the other way. Okay, so there is no lock-in is not a very general term that once you use something you cannot come out of it. So every architecture decision inherently imposes some form of restrictions. Okay, so you are fine with that in the given context. Once your scale increases, you will have to decide something to move it out. If it is not working out, you'll also have an option to kind of refactor and go with something more suitable. So I'll actually present 3 use cases. I I'll not fast track, I'll cover only those slides which make sense. I'll still go very slow and simple. There are 3 use cases that I want to present, because these are the people who actually took the right decision in their early stage and then built the platform and the overall system with the serverless that worked. Okay, the first one is online training platform. All of you have heard of Udemy? How many of you have heard of 𝐀𝐻𝐿? Okay. 𝐀𝐻𝐿 is a online cloud training company. They make a lot of videos, training materials to learn cloud and cloud native systems. So they actually build their original system. They redesign, but they quickly redesign and rebuild their original system around the serverless. They were big believers in the serverless. They realized that this technology or this architecture pattern allows them to actually convert their idea of creating an online platform and then go to the market, share the overall platform to their users much faster, and that actually happened. So this is the architecture diagram from them in 2015. This is available in Medium. I use this diagram very often just to, because it actually it allows me to explain the complicated part in a very simple way. If you just look at it, they have used different services, put them all together, and then they have built a platform out of it. For authentication, they are using Auth0. For the storage, they are using S3. Like Prashant mentioned, S3 was one of the first earliest serverless service in the storage space. Then for the internal APIs and everything, they use API Gateway. They were on time. They were building this, and the API Gateway was announced. So they rewrite some of that part and then make it compatible to API Gateway and Lambda. They use Firebase for the messaging, like we see in one of the previous example from Vishwasha, that the Firebase has achieved that level that the push notification has to be Firebase. It kind of becomes de facto. Even if in the middle of the night someone says that I want to send a push notification, what should I use? Use Firebase. It will always work. And for credit card, they use a Stripe. So this combination of utilizing different services, put it together, and then they knew that they are experimenting. They are starting something new. So they don't want to invest a lot in technology. They don't want to invest a lot into infrastructure, right architecture, doing everything right. They want to see that how people react, and that is only possible if you give something to the people first. Okay, so this is how they built their entire platform. It worked for them for next few years, and ultimately 𝐀𝐻𝐿 is now part of Pluralsight. I don't know their current architecture, how it looks like, but they are the earliest and the big believers in serverless, and this is something from 2015. This is 2023. The next one is a food hub. It's a 4th largest food ordering company in UK. Now I'm taking this example because we all know that food ordering is a very spiky kind of a use case, right? You don't know when people will come, but you still know that people will come around certain time. Weekends, one, holidays, another, especially some days on the night time, on regular days around the lunchtime. So they decided to use serverless because they think that this allows them to go to the market much faster. They don't need to invest a lot in building the entire application and use case by implementing everything on their own, and they can utilize the existing services. Now in this particular case, they use one service, AppSync. How many of you have used AppSync? It's an excellent service. It has one very key feature that's called subscription. That means if you are using AppSync, there is a way that you can actually push data from the backend to the front end. How many of you have worked with WebSocket? WebSockets are usually hard. Okay, it's not very simple thing to do. You have to manage a lot of things, and at scale that becomes much harder. Okay, because you need a handle to send the data back. So AppSync actually covers, AppSync has this inbuilt mechanism as part of the GraphQL protocol. So AppSync is a GraphQL kind of a service. serverless, fully serverless. I'm only including the services which are fully serverless. Okay, not something which is named serverless and then something else. All of these services, if you are utilizing, you pay for it. If you are not utilizing, you don't pay for it. Okay, I want to keep it very simple for these slides. So they processed 63 million orders in 2021. This is post COVID, okay, and they have a short video presentation in This Is My Architecture AWS, where they explained that how this technology allowed them to go to the market. This system is not an entire system. This system they built for the POS, the devices that they actually give and put inside the restaurants. And these POS systems, they receive the orders, they process the orders, and then they update the kind of status of the orders. So you can imagine that the use of the serverless with the bulk of an order, 63 million is a very big number, and that too with a very spiky nature of the business. It allowed them to actually serve and process all of these orders just fine. Okay, and that too within the context of the use case, because they are not always, this is not something that requires to have a high scale, high demand systems. It's not a Zomato. I understand it's not a Zomato, but again, not every company is a Zomato. Okay, so not every company will require the same high kind of a performance and high complexity of the system. The next one is specifically I like because I am from the developer background. So when the use cases involve something on the developer side, it makes it more kind of interesting. Snyk, how many of you have heard of? Okay, so it's a very popular. Just to say it is very popular might not be right, because they were in the top 20 of the Forbes Cloud 100 companies this year. So they are within the 20, top 10, 20. They build the security and availability scanning tools. And they built one major feature which is tightly integrated from the AWS code tools. This is code commit. I have a small screenshot. This is code pipeline, sorry. And in that, you can kind of, before the code, the purpose of the code pipeline is that you actually package and you want to deploy your changes into the different environment, whether it's for the QA, whether it's for the production or other things. And like one of the session of Vishwasha, the security is not just outside, it's inside as well. So in this case, they are scanning the source packages. The Lambda, although it runs in a very kind of a safest of the environment, but whatever you put inside the Lambda, you have to take care of it, right? And if you are a company who has not 5, I think 5 will be able to internally manage, but if you have 50, 100, 500 developers, they are utilizing services like this, it becomes very hard. Who puts what in their code, right? Nowadays we hear that a lot of open source libraries have a lot of malwares and vulnerabilities, because these ransom, not the ransomware, but these specific vulnerabilities, and then those developers are targeting the source packages, because that way they can get a wider kind of coverage. They can install their malwares into various source systems like a Log4j and a few others. So they built a kind of it has a direct integration using this. They use a serverless kind of a system to initiate the code scanning, okay, from the AWS code pipeline, and the entire unit runs full serverless. Again, they have also presented how they have done this at scale. They are using more than one serverless services, but the key one in this case is a step function. Now, step function is one of the most kind of I would say that promising services in the serverless. The reason is it allows you to put several things together, not for the simple, but for a very complicated workflows. And you will not have a fully functional production system without a workflow in place. There will be some kind of a workflow. So workflow is how the event moves, or how you want the particular use case to start and end. Okay, so step function is a kind of, in that term, it's a groundbreaking service which allows you to put a lot of these different services together and execute what you need to execute. So they use a step function in combination with API gateway, DynamoDB where they maintain the state, event bridge to kind of distribute the events, Lambda to execute the different code, and finally generate and save the result back into the S3 so that these results are available to the developer. So this is completely a different use case of serverless which runs entirely behind the scene but at scale. And Snyk is a very popular company, and they have their if you just look at the number of integration available, there are only 3 integration available. 2 are AWS and 1 is Snyk. So that's the level of integration they have with AWS. So you can also imagine the scale that it has. I'll try to wrap it up. I just wanted to explain that not every use case has to start very complicated, has to use the Kafka, or I even forgot the name. There are so many names. But not every use case has to start with a super complicated technologies. You can start something very simple, see if it works or not, adopt, evolve with that. If your business is evolving, you will be able to enhance your system. If your business is not evolving, those systems are not going to, those systems will become a burden, right? One or the other way, whether it's a technical debt, whether it's a cost or many other things. Scalable and reliable service. All of these services run at scale. Lambda does millions of execution every day. How any of you have wondered, AWS goes down, but it's a portion of that services that goes down. That too in a region or area. Otherwise, AWS, Google Cloud, Azure, all of these services 24/7 just runs. So those who design these services, what kind of a thought process they may have? Okay. So these are extremely scalable, extremely reliable services, and they are in production for years now. Pay as you use, that's my favorite because I want to get a maximum value out of what I use as a service. The same thing that we apply as a Gujarati, that if we are buying something, we try to assess, right, what exactly we are paying for. And infrastructure as a code. As Prashant rightly mentioned, the cloud changed one foundational and fundamental thing. That is, you can actually script your infrastructure. You can start when it's required. You can take it down when it is not required. So that's one of the key benefits of this entire serverless part as well, that you can actually control almost everything using the code as well. And event-driven architecture. Everything around us is an event, so I think it fits very naturally to the way we see the things around us. It's not one size fit for all, but it can coexist with any architecture, whether it's virtual machine, whether it's a container, Kubernetes, anything else. I'll just fast track this. Step function to me personally is the best. The services besides the Lambda, you need Lambda, but step function is right. Incognito is the best go-to service. You do not need to worry about how you will manage the, not just the user part, but the authentication and making sure that all of your endpoints are secure and you have the right auth attached to that. So I'll just take 30 seconds. So Berkeley Computing released a paper. It's a very well-known paper back in 2009 that they predicted that the cloud will kind of oversee a lot of, will overtake a lot of things. That was in 2009. It happened. So the same team at Berkeley, they released another paper in 2019, exactly 10 years after that initial paper, where they say that the future of cloud is serverless in general, serverless computing. The definition varies depending on the services or the marketing team and other things, but the overall idea is that you pay for what you get. Okay, so yes, there are hundreds of services available and not every services are serverless, but at the same time there are enough services available that you can actually utilize and to get the best value or maximum value out of it. Thank you.